The points A and B have position factors. Find the factor equation. So for the vector equation through A and B, we can use the point A or the point B, and the direction AB or BA. So the point A is 211 from here, 211, and for the the factor AB is the coordinates of B minus the coordinates of A. So 1 minus 2 is minus 1, and minus 2 minus 1 is minus 3, and 2 minus 1 is 1. That's how we get the factor AB. So this is the line equation. We have a point on the line and the direction of the line. Now acute angle between AB and L. So previously we know this is the line factor equation for the line through AB, and the direction of L from this, the direction is 1, 3, minus 2. This is the direction factor. So to find the angle, we use the dot product formula in the MF19. So if you rearrange this, make cos theta the subject, we have A dot B divided by magnitude of A times magnitude of B. So using this concept here, the factors we are using are the direction AB, which is minus 1, minus 3, 1, and the direction of the other line, which is 1, 3, minus 2. 1 minus 3 minus 2. Okay, so for the dot product, if you just follow this formula, we multiply the corresponding components, the x component, and so on. So minus 1 times 1, and minus 3 times minus 3, and 1 times minus 2. That's how we do the dot product. And for the magnitude, it's not in MF19. You can memorize the formula: square root of minus 1 squared, minus 3 squared, 1 squared, add everything, and we do it the same thing for the other factor. So from here we use a calculator. From the top we have 6, and from the square root here you get 11, and this is 14. And since we are looking for theta, not cos theta, we still have to do inverse cos. This is still cos theta, this is now the angle theta. Using a calculator you get 61.1 degrees. Now since we are looking for the acute angle, of course it's gonna be in the first quadrant, but sometimes when we do the dot product we can get something negative, and if we do inverse cos we're gonna get the supplementary angle, so 180 minus this angle. So when that happens, you can just do 180 minus that obtuse angle, or you can just ignore the minus, so just use the positive value and you get the acute angle or the quadrant 1 angle. Next part, show that they do not intersect. So we have the equation of the AB line from here before, and the equation of the other line is this one here. Now we make 3 equations using the corresponding components. So for the x component, 2 minus lambda, and for the x component here, 1 plus mu, and for the y component, 1 minus 3 lambda, 2 minus 3 mu. So now we're gonna solve for a lambda or mu. We can substitute or eliminate. So here we multiply the equation throughout by 3. So 2 times 3 minus 1 times 3, 1 times 3, 3, 1 times 3. We get this, and then we subtract to cancel out the lambda, and 6 minus 1 is 5, 3 minus 2 is 1, and 3 minus 3 is 6. And then subtract 1 from both sides, divide by 6, you get the mu. To find the lambda, we can just use one of the equations. Here we're using the first equation. We replace the mu with 2/3, and then we can just move this 2 to the right. So 1 plus 2/3 minus 2, that's gonna be minus 1/3. So the lambda is 1/3. And now we use the third component 1 plus lambda equals minus 3 minus 2 lambda. So this is the third equation. We plug in the lambda and the mu. So when we plug in lambda and the mu, we're gonna get something different. So this is how we show that the lines do not intersect. If they are the same, the line intersect. But since they are different, the lines do not intersect. Okay, so I'll see you again next